Hi there. I hope you remember we are finished in the last session a very good concept called determinants, and you saw the different stages of the concept which was covered in determinants, and finally we are into this matrices topic. It's a continuation of determinants, no doubt about it. But I don't want to explain much about matrices because I have an understanding that you have done this matrices in class 10, but I will just touch this particular basic part of this matrices. So as we saw in determinants, let us go with what is exactly matrices. So matrices is nothing but arrangement of elements in rows and columns in between square brackets. So namely, you can say suppose A, B, C, D. Consecutively, what is important for you to know? There is row 1, row 2, column 1 and column 2. This is what you need to understand and remember, that matrices is nothing but arrangement of elements in terms of rows and columns, and finally row 1, column 1, row 2, column 2 forms the part. The order of this matrix you already know, it is given in the form of m into n. In this case it is 2 rows and 2 columns. So m stands for number of rows and n stands for number of columns. This is the first part of matrix which you need to understand. We are going to do with around about 3 by 3 matrix, not 3 by 2 matrix or 1 by 2 matrix, except for basic questions which are done in class 10. So coming to the point, the first part is the definition, that a matrix is nothing but arrangement of numbers in rows and columns. First point. Now what is the thing which you are going to know? The first part is nothing but construction of matrix. So in the 10th standard they gave you the matrix and they asked you blah blah blah, but now they are asking us to find the matrix. So that is very very important. Now before we proceed, I want to just make you aware or educate you all on the position of the elements. Now the position of the elements begins this way. So just for your information, let me put across. So if I take this 2 by 2 matrix, remember this element is A11, this is A12, A21, A22. So when you did this understanding, A element, you see the first row, first column. So first row, first column. First row, second column. Second row, this is the first row, right? First row, this is first row, this is second row, first column, second row, second column. So this is what you need to understand, that element is its position, because based on this position, the general form of putting up this position is given with the element A and IJ format. This is very important. Now suppose if I ask you a simple question that construct, let us take a construction word, construct 2 by 2 matrix where Aij is given by, try to understand what I am giving, Aij is given by I plus j, a simple part. So first of all 2 by 2 matrix, that means 2 by 2 matrix will be corresponding to this particular elements A11, A12, A13. So let us talk about A11. So when I say A11, so A11, now I stands for 1, J stands for 1. So the corresponding element for A11 will be I plus J. This is the formula which is given for formation of the element. So 1 plus 1 will become 2. Similarly, I want to find A12. So A12 will be what? 1 plus 2, 3. Similarly, A21 will be 2 plus 1, 3. A22 is nothing but 2 plus 2, that is 4. So finally, what is the matrix from this I generate is nothing but 2, 3, 3, 4. So this is the first part you have to understand about construction of matrix. I hope you got this point clear. So let me take one more example so that you get an idea what I mean. Now suppose same thing if I say find say 2 by 2 matrix, right, 2 by 2 matrix. And if I say that construct a 2 by 2 matrix in such a way that Aij is nothing but I 2I plus j upon 2. Okay, I am taking just a pattern, a formula here, and to find the elements of that. So, first of all, you know that the matrix is given here. It is 2 by 2 matrix. So, it will be A11, A12, A21, A22. Now, how I get the elements? The elements are given in this format. If you see this part, this is the formula for determining the element. So, what happens, children? Now, if I look at the element here, let us see what generates coming to this. A11. So, in place of Aij, A11. So, I is 1, J is 1. So, 2 plus 1, 3, 3 upon 2. So, it is 3 upon 2. A12. So, 2 plus, sorry, 2 ones are 2 plus 2, because A12 means this is 1 and this is 2. So, 2 ones are 2 plus 2, it is 4 upon 2, that is 2. A21, so A21 will become 2 2s are 4, 4 plus 1, 5 upon 2, right. Then A22, 2 plus 2, 4, 4 plus 2, 6, 6 upon 2 is 3. So, what I want to stress my point over here is, I gave you a mechanism by which I can find the element, right, that is Aij I plus j. In this case, Aij 2I plus j upon 2, and I asked you what is the structure of the matrix, what is the order of the matrix. So, this is the first point in class 12 matrix you should remember, how to construct a matrix. A formula for the getting the element is given to you. They give you the order of the matrix, and accordingly you can just format the structure and find the corresponding elements by using this particular element formation formula. Now, once this is done, I think just understand now what you did today. You created a matrix. You created a matrix in this case. So, I believe this is the most important part of beginning with matrices. That is nothing but construction of matrix. I hope I have not stressed much on the structure of it. Remember this, because you already know what is a matrix. It is arrangement of numbers in terms of rows and columns in square brackets. So, that is where matrices. Now, we went one step ahead, that is construction of matrix. So, like this, what we are going to do is, in the beginning, in this session, we are going to study all the small concepts, and I am going to take you to, for each concept I will expose you to some examples, so that you understand what is the concept and how it is exactly applied in matrix. So, this is the first part. So, pause and note it down. So, here we go. After understanding how to construct a matrix, let us see the next concept which comes up in matrix, that is nothing but equality of matrix. But before we touch that equality of matrix, I just want to share with you some important thing which I will just share over here, okay, so that you understand exactly what other things which you know. First thing we should know is what is a square matrix. So, you all know what is a square matrix. I am not talking about all the different types of matrix. What I am interested, whatever is relevant and more important for 12th standard, that we are taking up. A square matrix is nothing but, you know what is a square matrix, children? It is m into n, where m is equal to n. Then I say it is a square matrix. Now, for example, in this case, it is 2, 2, 3, 1. So, 2 by 2 matrix. Similarly, 1, 3, 2, 1, 1, 1, 1, 2, 1, 3. So, this is nothing but 3 by 3. So, if you see this 3 by 3 matrix, 2 by 3, such matrix are called as square matrix. Next important matrix you need to understand and know is identity matrix. So, I2. So, I2 is nothing but the diagonal elements are 1 and remaining elements are 0. Similarly, identity matrix can also be called as 1 0 0, 0 1 0, 0 0 1. So, this is all important parts which I will just name it out now here. This is nothing but identity matrix. Now, this is not a denotion, this is just a denotion of how you denote an identity matrix. Now, this is besides this is certain things which you should know, because in some many sums, you will understand, you will see the situations like this. So you should know exactly what you mean by I. I doesn't stand for higher, okay? I stands for identity matrix. So children, let us begin with the next concept. After understanding what is construction of matrix, we go with equality. Now this is slightly important because the reason is, there can be some sums of 2 marks can be put across on equality of matrix. So what is exactly equality of matrix? So when I say, please pay attention now. Now suppose I just giving an example to you. So what is it example? It is suppose 1 x plus 1 3 5 and it is y minus 1 is equal to, okay, you can say minus 4 3 5 and it is 7. Okay. Now I had given you a situation where a matrix is equal to some matrix and I ask you find the value of x and y. Okay. The important point is, first thing is, two matrix can be equal. First and foremost condition is that they have to be the same order. Okay. Now what is the important point I want to stress is I need to find x and y. Find x and y. Now as you had studied in class 10, these are all revision of class 10 matrices we are doing, and as you go on you will see more and more new things are coming up. So find x and y. So this is the first thing what I want to share with you. So how I get x and y. Let us begin. Now as I said in matrix, every position of the elements are important. So if you see, the first element will always work with the first. It will not go and take on the second. Okay, keep that in mind. So first will go with first. Now as I want x and y, so I can, the first condition says x plus 1 is equal to minus 4. The first part. So what I can do is x equals to minus 4 minus 1. So x is nothing but minus 5. So this is the first working. Then second working is I want to find y. So y is nothing but the fourth element. So fourth element will correspond with the fourth element. So what will happen now here? Say y minus 1 is equal to 7. So y is nothing but 7 plus 1. So y is equal to 8. So my final value of the answers is nothing but x equals to 5 minus 5 and y is equal to 8. So this is basically equality of matrix. You had done many sums before, so I am not going to stress. As and when we will be doing examples, we will be doing more about it as we go on. But right now what is important from my side to put in front of your children is nothing but a matrix is equal to some matrix. So what is the important part is first to first, second to second, third to third and fourth element to fourth. So that's the correspondence way it works, and you find the value of x and y as the basic maths demands. So I hope you got this point clear, children, right? So pause and note it down. Okay, so on equality of matrices, what is the important point you are going to remember? That every element will be corresponding to its same position element of the next matrix. Okay, that is very, very important. So let us see this question now. There are just two options I had given to you. The first simple example. In the first case, they are asking x, y, z. In the second case, they are asking us x, y, z and w. Okay, find x, y, z and w. So children, let us begin with the first question which is there in front of us. So basically, as I said, the first element will be equal to the first. So what I can do is I can just generate the equation x plus y equals to 3. Okay, then if you can see here, if you see this particular part, this one, y minus x equals to 1. So from y minus x equals to 1, I can say, I can write it minus x plus y equals to 1, because the fourth element will correspond to the fourth. So this is very interesting fact here. Remember, the first element corresponds to the first element and this element is corresponding to this element. Keep that in mind, not this one. So coming to a point, I hope you got this message clear. So once you finish with this, let us take the next one also. Say this is y minus z is equal to, second will correspond to second, then z minus 2x. So I can just write here z minus 2x equals to, I think, third to third. So once you had worked out with this, what is important, you need to find x, y and z. So basically this is more simpler, because if I ask simultaneously I can solve this out. So this gets cancelled completely. So it becomes 2y is equal to 4. So if 2y is equal to 4, y I got 2. Now once this is done, I am ready. right? Because once you get y, you can find the value of x on your own. Take the first example. So what is given to you in this case? It is given x plus y is equal to 3. So if x plus y is equal to 3, what is the value of y? 2. So what is finally the x value you will get over here, children? So this will become a y value is 2. So x plus 2 is equal to 3. So take 2 this side. So finally x will be equals to 1. So once I got x equals to 1, children, that's fine. Now I got x equals to 1. I'm just rounding it off now here in this case, right? Now take it over here. You can get y value very easily. Y value is 2. So you can put here 2. Now look at this, 2 minus z is equal to minus 1. So what will happen is z can shift this side, minus 1 you can bring it over here. So 2 plus 1 is equal to z, which is giving you 3. So basically this is another situation we have got now. Basically we don't need this equation at all because we already found the x value, y value and z value. So that's the point. You just see what equations can match up with which equations and just work on and find the unknowns. It's such a simple question, but 2-mark section there is a possibility of these questions to be coming up in the board exam. Now if you want, you can confirm. Now from z minus 2x, what is the z value? You got 3, minus x is nothing but 1. So 3 minus 2 into 1. So 3 minus 2 is 1. So 1 is equal to 1. LH is equal to RHS. So this way you can verify the question also. But of course, we don't need to show that verification here in this case. I hope you got this point clear. So let us take a similar example on the right hand side. So what we see is you have to get the solution of it. Similarly, I have to go working of it. So first will be equal to first. So x minus y is equal to minus 1 and third is equal to third. So I can say 2x minus y equals to 0. Now what happens when we work with this matrix, children? I hope you know how we work it out. That is minus minus. So best is just subtract the second equation from the first one. So this is nothing but minus, this is plus. So what will happen finally? I can eliminate this y and this y. So what is the final result here? Minus x is equal to minus 1. So I got x is nothing but 1. Now once I get x as 1, children, I can get the value of y. How I get the value of y? I write the equation, first one, x minus y equals to minus 1. Now x value is 1. So 1 minus y is equal to minus 1. So finally y will be 2. So what I got, basically I got x equals to 1, I got y equals to 2. So I got x equals to 1, y equals to 2. Now I have to focus on z and w. Now once you finish z and w, look at the second element, I can say. You can say second element here. So second element you can say here, look at this, 2x plus z is equal to, this will correspond to this, is equal to 5. Now I don't have to work more because x value is 1. So substitute that x as 1. So 2 ones are 2. 2 plus z is equal to 5. So z is equal to 3. So what you got in this case? You got the z value also, right? So I have to get w now. So look at the fourth element, children. So fourth element also can work out. Fourth is equal to the fourth one. So I can say 3z plus w is equal to 13. So I already got z, that is 3 3s are 9. So 9 plus w is equal to 13. So I think w is nothing but 13 minus 9. So what is 13 minus 9? It is nothing but 4. So what I understand from all this, I got x, y, z, w. I had done nothing. Just correspond the position of the elements with the respective position in the second matrix and equate it, and then basic maths is calling. Solve it. That's it. I hope you got this point clear, children. So pause and note it down. These are very simple questions which I don't want anyone to just leave out just because you might have some doubt in class 10 matrices. Don't worry, whatever it is, the basic I'll be touching and progressing to the next part of the topic. I hope you got this point clear. So pause and note it down. Okay, I hope you remember we had finished with construction of matrix. Then we went into equality of matrix, dealing with defining the values of the unknowns. Now finally what we are going to do is we are going to go ahead with operations on matrices. This also you had done in class 10 in a very well way. Okay. So let us begin with that. So I'll just take an example directly and just scan it through you all, and then we will take some examples and solve basically how we go about this. I'll just take one example and then show you. Now for example, what is the operations on matrices we are talking about? We are talking about addition, you are talking about subtraction, you are talking about multiplication. These three operations you had studied in class 10. So let me just give an example to you. So suppose if I say A is nothing but 3 1 minus 1 2 and B is 1 minus 1 0 2, okay, and C is you can say 3 1 minus 1 minus 1. So I just added up this put up this 3 matrix for you. Now first operation for addition and subtraction I want to share with you, and then we will go into the multiplication with the same matrices. Okay, so let us begin with this. First thing, let us see how we go about with addition. The first and foremost, addition and subtraction of matrices is possible if they are of the same order. For example, if 2 by 2 matrix is there, you want to add subtract to other matrix, so that has to be of 2 by 2 order. You can't have 2 by 1 or 3 by 2. Both the matrix orders need to be same for addition or subtraction to take into effect. So if I just tell you, if I just share with you, find 2a minus 3b. Okay, let us take another example, one more, so that you get to know. For example, a second one, if I say 3a minus b plus c. Okay, so I had given you two different examples on operations, but in that operation, remember you are multiplying this matrix A by 2, B by 3, A by 3, B by 1, C by 1. So let us see what happens over here. So 2a minus 3b. So how I write it out? I will write here 2 into A matrix, 3, 1, minus 1, 2, right, minus 3 into B, that is 1, minus 1, 0 and 2. So you have done this part. So let us see what happens now. So this will become 6, 2, minus 2, 4. Remember, in determinant, when you took a number inside, it was able to multiply with any row or any column. It doesn't get multiplied with all the elements. So that's the difference between matrix and determinants procedures. That is the working procedure. So 2 3s are 6, 1, minus 2, 4. Similarly, keep that minus sign, don't get confused. So you can take this 3 inside, 3 minus 3, 0, 3 2s are 6. Now having done this, it is just a matrix subtracting by other matrix. As I said, the position of the elements are crucial. First we will be dealing with first, second will deal with second only. So what happens over here? The final answer will be 6 minus 3, that is nothing but 3. 2 minus of minus 3, 2 minus of minus 3 is plus 3. So 2 plus 3 is 5, minus 2 minus 0 is minus 2, and 4 minus 6 is finally minus 2. So this is nothing but 2a minus 3b. So that's the solution for this. So let us just take the same matrix and let us give it the example over here, 3a minus b plus c. So what is the working of it? So when I see that 3a minus b plus c, you have to just go ahead normal multiplication in this case. So for example, in this case now it will become 3 into a matrix, that is 3 1 minus 1 2, right, minus b is nothing but 1 minus 1 0 2, right, plus c is nothing but 3 1 minus 1 minus 1. Now you had seen this part. So now the same operation what you did over here, please go ahead with it. So what will happen over here? It is finally 3 3s are 9, 3 1s are 3, minus 3 6, minus this will become 1 minus 1 0 2, right, plus you can say 3 1 minus 1 minus 1. So this is what is important. Now if I talk about the working of this, so what will happen over here? Final matrix will come up. 9 minus 1 is 8, 8 plus 3 is 11, 9 minus of minus 1 is 10, that is, I mean to say 9 plus 1 is 10, 10 plus 1 is again 11. So what happens here? Minus 3 minus 1 is nothing but minus 4 in this case, then 6 minus 2 is 4, 4 minus 1 is nothing but 3. So this is what is basically addition and subtraction of matrices. We will be doing a lot of examples which involve all the operations of addition, subtraction and multiplication. I am just briefing you on this operation with simple example, and then we will go together into the examples from the exercise so that you understand, and it's the same thing what you did in class 10. Okay, it's nothing different in that. So I hope you got this point clear. So please pause and note it down, and this looks simple, but its application is very, very wide. Please take it down. Okay, now after seeing this addition and multiplication operations, addition and subtraction operations, children, let us go ahead with multiplication of matrices. This also I am very confident that you all have full knowledge about multiplication, but just from my side I will just work on with this particular order 2 by 2 matrix multiplication. The first thing very important is when a matrix can be multiplied by other matrix, that is the first thing you have to understand. So basically, now suppose a matrix is there over here. Okay, now another matrix is to be multiplied. So when I want to multiply these two matrix, children, remember, suppose the order of this is given as A into B. Okay, now remember, very important, A into B, and the order of this is given as B into, say, C. Okay, so the order is A into B, the order is B into C. First thing is, the first rule, like in addition and subtraction, two matrices can be added or subtracted if and only if they are of the same order. So similarly for multiplication also, what is the rule is that if a matrix is to be multiplied, should be multiplied with other matrix, then what happens, this column of the first matrix should be equal to the row of the second matrix. That means this part should be same, and the resulting matrix will be A into C. The resulting matrix will be A into C. So keep that in mind. Now for example, let me show you. Now suppose if it is given you 3, 2, 1, 4, okay, and I want to multiply with say 2, 1. So first of all, let us see what is the order of this. This order of this is 2 by 2. What is the order of this? It is 2 rows into 1 column. So basically, if you see carefully in this case, the column of the first matrix is same as the row of the second matrix. So this is the condition. If they both are same, then only you can multiply the two matrices, and final the matrix will be nothing but 2 into 1 order. So this is very, very important for you all to understand. But of course, we are dealing with situation where you can multiply a matrix by other other matrix, etc. continuously. So there is no issue at all about discussing this. But what is important, just need to remember, especially for entrance examination, some sums can be thrown at you all based on these ideas of multiplication of matrices. So anyway, now an example has been put to you in front of you, that is A is given. Find the value of A square. Now basically don't have that misconception, A square means square the element, 1 square is 1, minus 1 square is 1, 2 square is 4, 3 square is 1. That doesn't work over here. Okay, so I want to find A square. So basically A square in matrix format is nothing but A multiplied by A. Now let us talk about multiplication of two matrices. Okay, now the order is 2 by 2, so I have no issue. So I will just write the matrix 1 minus 1, 2, 3. Okay. Similarly, if I look at this, that is 2, 3. Similarly, it is 1 minus 1, 2, 3. Now what I do? Now whenever you are multiplying a matrix by another matrix, remember this fundamental rule. This is the fundamental rule. Now by the way, what is this fundamental rule? This is matrix 1 and this is matrix 2. So matrix 1 you always consider the row, and matrix 2 you always consider the column. So whenever you are multiplying, you multiply a row into column. Now how I do? Let us take it this way now. Now if you feel that something is working here, I'll just show you some explanation here. Now hide this 2 and 3. This has to be hidden. So first row into all the columns, column 1, column 2. So first row multiply by all the columns. Remember, row into column will give you one element. So how I do that? Pay attention now. So this is the row, right? This row has to be multiplied by each column of the second matrix. So that's why row of the first matrix, column of the second matrix. So row 1 into column 1. So this will be nothing but row 1 into column 1. I wrote like this. Then row 1 into column 2. Row 1 into column 2. Then row 1, any column 3 is left out? No. So leave that. Then row 2. If you see this, row 2 into column 1 and row 2 into column 2. So basically what we are doing, we are just multiplying a row into column. And what is important for you to understand is a row into column will always fetch you one particular element. So in this example, what will happen? I will just share with you. Now look at this properly. Row 1 into column 1. So basically it is like this, 1 minus 1, 1, 2. So first with first plus second with second. So understand this working also, children, because this is something very, very important for you all to understand. So row 1 into column 1. So row 1. So 1 ones are 1 minus 2. So 1 minus 2. Row 1 into column 1 is one element. Then row 1 into column 2, which I post over here. So 1 into minus 1 is minus 1, minus 1, minus 3. This already you know how to do it, but still I am just working. 2 ones are 2 plus 6. So 2 plus 6. What I did, second row now, first row has been multiplied by all the columns. Now forget the first row. Now second row with all the columns. So 2 ones are 2, 3 twos are 6. Then 2 into minus 1. Now second row, first column is over, second row, second column. 2 into minus 1 is minus 2 and 3 into 3 is 9. So basically what it gives you nothing but, I think it is minus 1, minus 4, 8 and 9 minus 2, that is 7. So this is the way you do with a square. Now you might ask me, sir, what is this? A square I got, now I have to get a cube. So a cube has to be same thing. Please try it yourself. You also try, I also work on it, right? And let us see whether we can get the solution on our own. So what is a cube? Now in this a cube, one thing you can do is a square into a. A square already got over here, a square already got. So you can just write minus 1, minus 4, 8 and 7 into a. Now what is my a matrix? It is given here, 1, minus 1, 2, 3. So basically children, you know these things, but still I am working on it so that anybody who has missed the boat, they can just understand how to do it. So let us do this matrix multiplication now. First row, as I said, all rows with columns, that is row 1 with all the columns of the second matrix. So hide the second row now. So row 1 into column 1. So minus 1, minus 8, minus 9. Minus into minus, plus 1, minus 12, minus 11. Then 8 ones are 8, 7 twos are 14. So 8 ones are 8. Second row and first column. 8 ones are 8, 7 twos are 14. That is nothing but 22. Then minus 8 plus 21. Now understand this, minus 8 plus 21. So 21 minus 8, how much? 21 minus 8 is 13, right? So 13 will come up here. So this is what you have to understand here. So understand 8 minus 7 is 21 is 13. So this is what. So basically when I am doing a cube, it is a square into a. So first I already got a square. So I am utilizing this a square over here, and a square into a, I am getting the solution. So basically this is what is multiplication of matrices. Now what I am going to do is I am going to go with sums, examples to you all from the exercise which has the combination of addition, subtraction and multiplication. Right. So and as we go on, I will explaining this process again and again in every sum. So just relax, take your seat back and pause and note it down. Okay, let's have a look at these examples now. We will be dealing with examples pertaining to the operations of matrices which you have done in class 10. So you may say why you are doing it, because sometimes look at this pattern of the sum. They had given a different format. The thing you are doing the same thing what you did in class 10, but the format of representing the matrix is something different. So these some new things you will learn as we are going on with some examples on addition, subtraction and multiplication matrix. So the example 1 is coming up to you all to understand. Let us take the first one. They are telling us a very simple question, find x if 3a minus 2b plus x equals to 0. Now this type of questions are very, very common in class 10. So let us begin with this. I want to find matrix x. Now remember this you just treat as an equation. Now suppose if I want to have a matrix X, or for example it's a variable, so I will keep the X on this side and take everything on the other side. So same approach you can have in this case. So what I can do is I can say X is equal to 2b minus 3a. I can keep the X that side because I want the order of the matrix as X. I mean to say I want the matrix X. So I want to find matrix, I'm going to keep the matrix alone and just shift it this side. Okay. Now what I'm going to do over here is 2b minus 3a. So what is the thing? So X is nothing but, so the matrix X is given as twice into B. So B is already given to you, minus 2, 1, 3, 2, minus 3 times A. So I think you can write here 3. A is nothing but 4, 2, 1, 3. Now it is just simple multiplication, a matrix by a scalar, children. So I think you can definitely go ahead, minus 4, 2, 6, 4, minus outside 12, 6, 3, 9. Now once this is done, so the matrix X is finally, understand, minus 4 minus 12 is minus 16, right, and 2 minus 6 is minus 4, 6 minus 3 is 3, 4 minus 9 is minus 5. I hope you got this point clear. So what I did, minus 4 minus 12 is minus 16, 2 minus 6 is minus 4, 6 minus 3 is 3, 4 minus 9 is minus 5. So this is what exactly I am looking for. So these type of equations are simple, what do you say, this type of sums examples are simple examples, but a good point to understand. Now I want to modify this question because I just want to remind you something. Now suppose if I do plus 7. Okay, now you might be a little bit perplexed, sir, how you can add a matrix to a number. A matrix can be added to a matrix only. A matrix can be subtracted from a matrix only. How can I add a matrix to a number? So remember one thing, I purposely had put up that particular point over here so that we don't miss out those points. There is no issue with 2a plus 3b and plus 7. Now remember, this is nothing but I. You can't add a matrix to a number. You can multiply a matrix by a number but not add. So what I do, it is understood when they mention 7, it is understood it is 7i. Okay, so now I think the working is very easy, but as soon as I look at the matrix, it is given diagonal 3 minus 2 1. You know what does that mean? I'll just show you. So A matrix, so it is like this, twice of A. Now these are the diagonal elements. So 3 minus 2 1, A matrix, remaining will be 0. Right. Similarly here, minus 3 diagonal 1 3 minus 2. So this is 0 0 0 0 0 0 and plus 7i. I'll just take that 7i this side because plus 7i write here or here, it doesn't make any difference. So I'll just write this 7i, I'll take it later on. Okay, so once you finish with this, 2 3s are 6, 6 minus 3 is 3, right? Then it is 0, 0, 0, minus 4 minus 9, minus 4 minus 9 is minus 13, then 0, 0, 0, 2 plus 6 is 7. Now plus 7 I can go ahead, so 7 0 0, remember 0 7 0 0 0 7. Now let me work out with this now directly because there was no space, otherwise you can just take that 7i over there and just work out on your way. So basically this is the part, 3 plus 7 is 10, then 0 0, then 0 minus 13 plus 7, minus 13 plus 7 is minus, I think minus 6, then 0 here, then 0 0, 7 plus 7, answer is 14. So this is what basic idea is, what you mean by diagonal and putting across in the diagonal format. So I hope you got the two structure here. It's an equation type which involves addition, subtraction. Here two things you should remember. Diagonal representation is this way. That means the other elements of this particular matrix is 0 0, and finally if it is added to a number, it is 7i. Keep that in always in mind. Okay. So this is the way you have to work out with the first example of a operation based on operational matrices. So pause and note it down. Okay, let us see the second example, children. Here It is find A and B. If you see this sum 3 into what matrix, whatever stuff it is, the order is whatever different it is, but it involves the addition, subtraction and multiplication of matrices. So that's what we are going to do. Good examples, as we go on. It's make it a point that I'll explain to each and every part of it. So let us begin with this question now. It is given 3, 2, 1 minus 3. So first of all, you see these brackets are very important. First always identify the structure of the sum. If you see this bracket is closing over here, it means you have to shrink it and make it 1 first. Okay, and then this whatever matrix you get, you have to multiply with the other matrix. So let us begin with the question now. So what happens is I can just put across the bracket so that it becomes clear. So if I take this matrix here, it will become 3 2 is 6, 3 minus 9, 3, 12, 6. Okay. Finally, what happens here? Minus, this will become 2 minus 4. Don't take the minus sign. There might be a possibility that you might go wrong also. Okay. So 2 minus 4, that is 0, then minus 4, sorry, 2 2s are 4, then minus 2, 6. Okay, end it up, and then finally 2 0 minus 1 is given as A into B format. So let us begin. This matrix has to be clubbed and formed into 1. So this matrix will be something like this, that is 6 minus 2, that is 4, 3 minus of minus 4 is 7, minus 9 minus 0 is minus 9, minus 1, 14, 0. And this matrix, okay, has to be multiplied by this matrix, okay, is equal to A and B. Now remember, there is a multiplication between matrix, but I told you whenever your matrix multiplying, you are doing it, remember row of the first matrix into column of the second matrix. So first step, first row into all the columns. There is only one column, so first row into first column. So finally this will be like this, which is equal to A and B. Now don't worry about the order, it will automatically generate. So row 1 into column 1, row 1. So multiply the row with all the columns of the second matrix. So 4 2s are 8 plus 0 minus of minus is plus 9. So first row into first column. I told you first row, any row into column will give you always one element. Keep that in mind. Okay. So row 1 into column 1. Row 1 into column 2 is there in this case? No. So leave that. The row 1 row is over. Now row 2. So all the rows of the first matrix should be multiplied with all the columns of the second matrix. So row 2. So minus 2 plus 0 plus 0. So finally you can get it over here, that is 8 plus 9 is 17 and minus 2 is the final answer. So A is 17, B is minus 2. So I hope you got this point clear, children. Don't get confused. Remember the operations what you have to do. First shrink it because there is a bracket you got into one single matrix, and this matrix will multiply with the other matrix. So again we will be seeing more and more questions on the mix up of addition, subtraction and multiplication operations on matrices. So pause and note it down. Okay, this is the next question, children, which is on A is equal to 134 minus 3, find A square, A cube, f of A, if f of x is this thing. Now this is also one of the very patent question for a ISC board exam. You might not have seen this in your class 10 type. This you must have seen, but this you must not have seen. Anyway, whatever it is, let us just pursue it. First thing, let us get A square. So let us begin. A square, I told you, we don't square the elements. A square is A into A. So let us begin with the first question here. I can put it over here, A square. So A square is nothing but A into A, that is 1, 3, 4 minus 3, 1, 3, 4 minus 3. So you know how to multiply the two matrices, right? First row into all the columns of the second matrix. So what happens now? Now I am going to do directly here. First row into first column, that is 1 1s are 1 plus 12. So 1 1s are 1, 3 4s are 12. Similarly, first row into second column, 1 3s are 3, 3 into minus 3 is minus 9. Now first row, first column is over, first row, second column is over. Now first row, third column, there is no third column. So your first row finishes. So multiply the row, first row with all the columns. Similarly, multiply the second row with all the columns of the second matrix. So 4 ones are 4 minus 12. Second row, first column, second row, second column. So 4 threes are 12 minus 9. So finally what happens, children, over here, if you look at this, it is 12 plus 1, that is 13, 3 minus 9 is minus 8, 4 minus 12 is minus 8, and 12 minus 9 is nothing but 3. So I got a square, children. So let us get a cube. The next part is finding a cube. So a cube, I will write here B section, a cube. Now a cube, you can say it is a square into a, because a cube you can just bifurcate in this way. So a square, I already got a square right now, so I am going to use this part. So it will be 13 minus 8 and 3 into A. Now what is A matrix is given to you, 1, 3, 4, minus 3. So let us multiply now first row into all the columns. So let us begin with a broader way. So first row into first column. So 13 ones are 13 minus 8 into 4. So minus 32. So 32 minus 13. So 32 minus 13, what is this? Check it yourself. Fast. Okay, 13 ones are 13, 4 is a 32, 32 minus 12 you can take up, 32 minus 12 is 20, minus 1 19. So I think 19 would be the answer, that is minus 19. Similarly, 13 into first column is over, 13 into second column, 13 threes are 39 and 8 threes are 24, 39 plus 24. Okay, don't get confused there, 13 threes are 39, 8 threes are 24. So 39 plus 4, 43 plus 20, 63. So carefully do it, don't be in a hurry. Minus 8, 3 fours are 12. So minus 8 plus 12 is nothing but 4. Then minus 24 minus 9, minus 33. So this is what I got a cube. Now finally what we are left out is this part. Now I wanted to focus on this part because this I think most of you know how to do it. Okay, this is the C part. They are asking f of a. So when I say f of x is already given to you. So what will be f of a in this case? If you look at this, what will be f of a? F of a. So x is replaced by a. So this will become 2a cube minus 4a plus 5 number. So what I told you in the previous sum, 5i. So now I can do this very carefully. I got a cube, I got a over here, just put it into the action mode and get the answer. So f of a will be a cube. I mean to say twice of a cube. So twice of a cube is minus 19, 63, 4 and minus 33, right? Then minus 4a. So you can say 4 times a. A is already given to you, right? Okay, 4a is 1, 3, 4 minus 3 plus 5i. I keep it as it is. I just take it down properly and push it off, which is equal to. So you know how to do this part. So minus 38, 126, 8, then minus 66. Okay, take this minus sign outside only. 4 ones are 4, 4 threes are 12, 16 and minus 12 plus 5i. So plus 5i keep as it is. So which is equals to, now you know minus 38 minus 4 is nothing but minus 38 minus 4 minus 42. 126 minus 12 is 114. Then 8 minus 16, 8 minus 16, 8 minus 16, it is minus 8, and minus 66 minus 12, it is nothing but minus 78. Now it is plus 5i, so 5i is nothing but 5005. Now work it out. This is the final answer in this case now, and you finish off on your own. So do it out. Minus 42 plus 5. So minus 42 plus 5 it become for 37, right? Minus 37, 114 minus 8 and minus 78 plus 5, it is nothing but minus 73. So, basically what I am doing is I am doing the multiplication, and I am doing the multiplication, addition as well as subtraction. So, this is the combination of all the examples what we have taken. I hope you have made yourself in a comfortable here. Be careful, don't do mistake, because one small element wrong, the marks goes out fully. Keep that in mind. Okay, so pause and note it down. Hi there. This will be the last example of this session. We will be doing lots of examples further. But I just want to make a note of this question. Very nice. As we are going into question to question, you are finding the complexity of it is slightly increasing. So that's the way, I want to go into that particular topic, so that you don't feel the pinch also, and at the same time you are learning also to the best of your ability. So here order is 3 by 3, whatever order, the procedure and the concept remains the same. They are asking find a square minus 5a plus 4i, and hence find matrix X such that a square minus 5a plus 4i plus x equals to 0. So that's a different question. This is a different question. So first let me focus on this part, because I have to get a square minus 5a plus 4i. What I suggest is find separately, individually all the things, and then you can club it into the particular solution. So let us begin with a square. So you know that a square is nothing but a into a, right? So you can have the working here itself, there is no problem. So, or you can have the working down. Okay, I just write it over here. A square will be 2 0 1 2 1 3 1 minus 1 0. So finally once again that is 2 0 1 2 1 3 1 minus 1 0. Now there is no need to show the intermediate step. You can directly get the element when you are multiplying a row by a column. So what would happen? So a square will be, I am just putting across here, column 1. Remember this, all row of the first matrix should be multiplied with all the columns. So row 1 into column 1. 2 2s are 4, 0, 1. So that is nothing but 5. Row 1 into column 2, 0, 0, minus 1. Row 1 into column 3, 2, 0, 0. So row 1 are multiply with all the columns, row 1 is over. Now row 2 multiply with all the columns. So row 2 into column 1, 2 ones are 2 plus 2 plus 3, that is 7. 0, row 2 into column 2, 0, 1 minus 3, minus 2. Then row 2 into column 3, 2 plus 3, that is 5, and 3 into 0 is 0. So 1, row 3 into column 1, 2 minus 2, 0, it is 0. Then 0 minus 1, 0. 1 minus 3, minus 2. So once you are done with this a square, I got the working done, correct? So now I want phi a. Now look at this phi a I want, so I will just put across phi a over here. So phi a, you can just have, a is already given to you, so phi 2s are 10, 0, 5, then phi 2s are 10, 1, that is 5, 3s are 15, then phi 1s are 5, minus 5 and 0. So once you get it, I have to get plus 4i also, but there is no need to get 4i, you can just work on with the solution right away. Okay, so what I am going to do, I am going to get 4i over this side. I mean to say, okay, 4i you can get it over here, and then you can merge up this way. So 4i, 4 0 0 0 4 0 0 0 4. Now you have got all these three parts. Now I will start working and getting this particular solution. Okay, so what I'm going to do over here, just place it up properly here. So I'll just write it properly. So this will be a square minus 5a plus 4i. Please check on with this particular part. Okay, now a square, I already got it here. So I'll just put across here. This is 5 minus 1 2, 7 minus 2 5, and 0 minus 1 minus 2, right, minus 5a. So, phi A is given here 10, 0, 5, 10, 5, 15, right, and 5 minus 5, 0. Then plus 4i, so everybody knows 4, 0, 0, 0, 4, 0, 0, 0, 4. So, you can just simplify this now, directly you can get the answer in this case. So, this operation will be, that is 5 minus 10 is minus 5 plus 4 minus 1, minus 1 minus 0, 0. So, minus 1, 2 minus 5 minus 3, 7 minus 10 minus 3, minus 2 minus 5 minus 7 plus 4 minus 7 plus 4 minus 3, then 5 minus 15 minus 10 will be as it is, because the third element will be 0 in this case, 0 minus 5 minus 5, minus 1 minus of minus 5 is plus 5, and here it is 5 minus 1, that is 4, minus 2 minus 0. So, minus 2 minus out minus 2 plus 4 is nothing but 2. So, I got the operation, the value of this particular pattern of sum, that is this value. What they are asking you in this question, look at the question, they are asking find x, that second question. I got the question here, solution for this. Then find matrix x such that a square minus 5a plus 4i, same thing. Now, what you can see, I want to show you something which you will be surprised. Can I write x is a matrix? So, can I write x as minus of a square minus 5a plus 4i? Check, this goes this side, and this already you have the answer here. So, minus of that. So, finally, I think x will be minus of this matrix. So, 1 minus of minus 1 is 1, minus of minus 3 is 3, minus of minus 3 is 3, 3, 10, here it is 5, here it is minus 4, here it is minus 2. So, basically this is a very simple sum, but the working of this a square I got 5a, I got 4i, I take it and put it here and got the operation done, and after this I finally got the equation x, that is the matrix x, I got it. That is the way you have to deal with this question. So, the question looks big, but the working is very, very basic matrices. So, just keep that in mind. So, I hope you understood this question, children. So, my focus for today was to just make you understand how we go with addition, subtraction and multiplication of matrices. We will definitely do some more questions in the next session. So, till then, pause and note it down.